Hello, math learners. This video, we are continuing to talk about the convergence of power series. So in the previous video, we introduced how to use the ratio test to determine what values of x make a power series converge. And in this video, we will do another example. So our previous video did this example here. And now we're going to look at this example here. We've got the sum from n equals 0 to infinity of n squared times x to the n. Okay, so here is the power series that we're working with. We want to know what is the radius of convergence for this series. Okay, so what we need to do is we need to take the limit as n goes to infinity of the absolute value of an plus 1 over an, and we need to work with that. So let's figure out what this looks like. First of all, what is an? This is our an here. So an is equal to n squared times x to the n. Then that means that the next term, an plus 1, is equal to n plus 1 squared times x to the n plus 1. In other words, we looked at an and just replaced all the n's with n plus 1s. Now I like to just clean things up a bit right away. X to the n plus 1 is the same thing as x to the n times x. Okay, so the limit as n goes to infinity of an plus 1 over an, absolute valued, is equal to, up in our numerator, we've got n plus 1 squared times xn times x, all that absolute valued. And then in the denominator, we've got n squared times x to the n. And again, throw absolute values around the denominator. Now we can see we have some nice cancellation. We can cancel the x to the n's from the numerator and the denominator. So now we've just got the limit as n goes to infinity of the absolute value of n plus 1 squared times x over n squared. Now, when we send n to infinity, we see that this will have the form infinity over infinity, so we need to use L'Hopital's rule, no problem. Let's go ahead and take the derivative of the numerator. We get 2 times n plus 1 times x. And then the derivative of our denominator is 2n. Now we see that we have 2's in both the numerator and denominator, so we'll just go ahead and cancel those out right away just to clean things up. Now, this still has the form infinity over infinity, so use L'Hopital's rule one more time. And we end up with absolute value of x divided by 1. Or in other words, just the absolute value of x. Okay, so this is equal to the absolute value of x. So since this is neither 0 nor infinity, we're going to set this to be less than 1. Now this means that our radius of convergence is 1. And that's because that is the number that we have right there. All right, so that is an example where we have found the radius of convergence for a series. I'll do at least one more example.